Okay, so hello and welcome back. So in this video we want to talk a little bit about switches. So basically a switch is something like, or basically a mechanical switch. There is something, of course, in electronics, as you might already know, there is something called a mechanical switch. A mechanical switch. Now what this mechanical switch looks like, it's basically something like this. So for example, if you go to Google and mechanical switch, electronics, for example, so this might be a mechanical switch, or this is something like this, for example. You see over here, for example, these are rotary switches, these are push button switches, these are toggle switches, these are dynamite plunger switches, this is a dip switch, and this is a slide switch. This is also some sort of switch which is called a I have forgotten the name actually. These were very popular, and so on and so forth. But basically what these, for example, as you can see over here, this is single, and there is some terminology related to these switches that you need to understand. So first of all, what these switches do is that they connect. Basically there are 2 points that will be connected or disconnected through the switch, meaning that when this lever over here is up here, the two terminals over here are not connected. When the lever is down here, the two points are connected, and the two points over here are short circuited. And this lever is basically this handle over here that you can turn to the left or to the right, and then in one position the two poles are connected, in one position the two poles are disconnected. Now there is another thing over here called a single pole, for example, double throw switch. So a single pole, for example, double throw switch is this kind of switch. As you can see, you have only 3 poles, 3 contacts over here, and one of the contacts over here is common between the two, meaning that in one position the common is connected to the contact up here. In the other position, the common contact is connected to the one down here. So the common is either connected to the contact up here or to the one down here. So that's called a single pole double throw switch. And as opposed to the single pole, there is also double pole double throw switch. So double pole means that you have two of these switches in one package, and that looks like, schematically, it looks like something like this, and it's, as a switch, it would look like this. You have basically 3 contacts up here, 3 contacts down here, and then as you move this lever to the right or to the left, then basically, suppose usually the common one is the one in the middle. So the middle one is either connected to the one to the right or to the left, and the other way around, and vice versa. So there are 2 things in these switches. There is the pole and there is the throw. So for example, when you write single pole, for example, double throw, something like this. This stands for single pole. This stands for single pole double throw. When you write DPDT, that means double pole. That means double pole, double throw. Double throw. Now what that means is that it's a little bit confusing to me, and it's not very easy to remember, but from here you can easily see that. So this is a single pole switch, this is a double pole switch, meaning that the pole basically refers to the number of, well, the number of single switches that you have in one package. So you see that in a double pole package, for example, you have actually two switches in one package. So that is referred to as the pole. So here this is a double pole switch, this is a single pole switch. Now the throw refers to basically now for example, when you say double throw, what that means is that you see, for example, over here this is a single throw switch, meaning that you have only two contacts here. The two contacts are either connected or disconnected, so that's a single throw switch, single throw. But when there is a common contact either connected to this one or to this one, that's then called a double throw switch, meaning that one of them is a common, and then it's either connected to the one to the top or connected to the one to the bottom. So this is a single throw switch, this is a double throw switch, this is a double pole switch, this is a single pole switch. So that's basically all about switches. Now some information about switches. Basically, the most familiar use is that of applying power to turn a device on or off. For example, a very familiar usage of switches is basically there is a light switch, for example, on the wall when you enter your room, and when you want to turn on the lamp, for example, you turn that switch, and then the lamp in your room is turned on or off using that switch. So that's what simply a switch does, meaning that it's usually, for example, let's say that this is a lamp over here, and then this lamp is connected. If the lamp is connected to the power supply directly, then the lamp is always, of course, on, and there is no way to turn the lamp off. This is the V of S, and this is your R, for example. There is no way to turn this lamp on, this lamp off, I'm sorry. Now suppose that I put a switch over here. Suppose that I put a switch over here, something like this, and then the switch is usually drawn like this. If I put a switch over here, whenever these two contacts are connected, then the lamp is on. Whenever the two contacts are disconnected, the power supply is disconnected from the, meaning that one of the wires is effectively disconnected and the lamp turns off, basically. So that's what the switch does, and as you can see, it's put in, it's basically connected in series with the load, and in series with the power supply. Okay. Now if you have a switch like this, and I showed you the switches over there on the internet, if you have a switch like this, this is called a, so suppose that this is one pole of the switch, this is one pole, and this is another pole, and this is the lever that I showed you. So this is a basically single, this is a double throw switch. This is a double throw switch. This is a double throw switch. So double throw switch because basically this common contact is either connected to this contact or to this contact, and it is a single pole switch. Single pole switch. Single pole meaning that there is only one switch over here. But if you had something like this, for example, if you had something like this and this over here and this over here in one package over here, and then this was connected to out and out here, and this there would be a switch over here and one switch over here. So now you can see that each of these switches is a double throw switch. So this is double throw switch, this is a double throw switch, and you have two poles. You have one pole over here and you have one pole over here. So this is a double pole, this is a double pole, double throw switch, DP/DT. Okay, so these terms are important when you want to, well, talk about switches, or when someone talks about switches they use these terms, or when you want to basically when you want to order switches on the internet, you usually use this terminology in order to refer to these switches. And there is some theory, or there is some information about these switches over here that we can talk about, and that is a closed or on switch has the total circuit current flowing through it, meaning that if you have a lamp over here and you're basically connected to the switch over here and connected to the lamp over here, and let's say that your switch is basically connected, this is your switch. This is your switch. This is your switch. Now if the switch, this is a closed switch right now, this is called a closed switch. So when the switch is closed, the current is flowing through the switch, the total current of the circuit is flowing through the switch, and then the lamp is turned on, of course. And technically we say that there is no voltage drop across the terminals of the switch because the resistance of the switch is zero. So when your resistance is zero, of course there can be no voltage drop across the terminals of the switch, meaning that the voltage drop is V is equal to IR, and if you have some resistance over here, for example, let's say that you have for example this let's say that you have this circuit over here. Let's say that this is R1 and this is R2 and this is V of S. Now the current that is going through this circuit, first of all, the equivalent resistance of this circuit, R of EQ, is equal to R1 plus R2. R1 plus R2. And the current going through this circuit, or I of T, I of t. So we know that V is equal to IR, so I is equal to V to R. I is equal to V to R. So that means that I of t is equal to V of S divided by R. Now, the equivalent resistance over here is R1 plus R2. Okay? So the current that is going through this circuit is actually nothing but V of S, the voltage, the power supply voltage, divided by R1 plus R2. That means that the same current is going through this resistor and the same current is going through this resistor because this is a series circuit. Now, there is some voltage drop across R1 and some voltage drop across R2, and since you have this series circuit, there is some voltage drop across R1 which I denote as V of R1. There is some voltage drop across R2, I call it V of R2. Okay? And this and V of R1 plus V of R2 in a series circuit is always equal to the power supply voltage. Meaning that in a series circuit, whenever you measure your power supply voltage, some of this voltage is dropped across this resistor, and some of this voltage is dropped across this resistor. And if you had another resistor as well, of course there would be some voltage drop across that resistor as well. As many, I mean that the voltage would be basically divided between as many resistors as you might have. And that's basically this circuit. Now, this voltage drop is equal to basically V of R1, for example, V of R1 is equal to basically well, I times R, of course. V is equal to IR. So the current that is going through this resistor was basically V of S divided by R1 plus R2. R1 plus R2. And now we said that basically V is equal to I times R. So this is I times R1. So R1 is over here times R1. So that what that means is that then V of R1 is equal to R1 over R1 plus R2. R1 plus R2 times V of S. So this is the voltage drop across the first resistor. And by the same logic, V of R2 is equal to R2 over R1 plus R2 times V of S. And that is basically the voltage drop across R2. And then if you add these two together, V of R1 plus V of R2, what you will get is basically R1 times V of S over R1 plus R2 plus, this is equal to, plus R2 times V of S over R1 plus R2 is equal to R1 plus R2, and over here you have R1 times V of S plus R2 times V of S. So I can take basically V of S out here. I can take V of S out and write it as R1 plus R2 over R1 plus R2. And as you can see, these two will cancel out and you will be left with V of S. That means that the voltage drop across the two resistors, V of R1 plus V of R2, I started over here with V of R1 plus V of R2, and I wrote these two relationships for V of R1 and V of R2, and then I was left with V of S. And that's basically what happens every time, all the time, in series circuits. The voltage drop across each of these resistors is equal to the power supply voltage. Now, of course, as you can see in this relationship, of course, the current is going through the circuit. Now, if R is equal to 0, then 0 times I is going to be 0, meaning the voltage drop across those two terminals, or across the terminals of your switch, is going to be 0. So that means that the higher the resistance, the higher is going to be the voltage drop across the terminals of whatever you might have over here. So, and what happens is that, as opposed to this idea of the switch being closed, you can also have your switch being open, meaning that you could have your lamp over here, and this could be connected to a switch, and this switch is connected to a power supply, for example, and that's your circuit. Now, if your switch is open, this is an open switch. Your switch is open, your lamp is not glowing. Your lamp is not glowing. Your lamp is turned off. Now, the whole power supply voltage V of S is dropped at these two terminals. So if you basically measure your voltage over here, you will have V of S across these two terminals. This would be your negative and this would be your positive, assuming that this is your positive and this is your negative. So an open or off switch has no current flowing through it. Of course, there is no current flowing through this because the circuit is open, and the full circuit voltage appears between its terminals. And in the beginning, it kind of didn't feel right to me that the whole voltage supply would appear on these terminals, but I actually did go through this book twice. I have gone through this book once before, and I happened to actually do this practically using a simple circuit on a breadboard. And what I found out was that the whole basically power supply voltage actually does drop across the terminals of your switch. Now, suppose that you have a circuit over here. Suppose that you have a circuit over here. You have a power supply over here, 10 volts, going to a switch which is closed, and then this goes to a 10 ohm resistor, and this goes to basically to the other end of the battery. This is positive, negative 10 volts, and this is 10 ohms, and this is a closed switch. I want to know what is the current flowing through the switch. So of course the current flowing through this switch is the current flowing through the whole circuit, meaning that because this is just a series circuit or a simple circuit, the current flowing through the current that's flowing through the switch is flowing through the resistor, flowing through these points, through the battery, and back and forth, and so on and so forth. So this is basically your I of t, for example. Excuse me. This is, for example, your I of t. Now, to calculate the current, you can use the Ohm's law. V is equal to I times R. So your V is equal to 10 volts, and your I is equal to, well, let's call it I times R, which is 10 ohms. So your I is equal to 10 divided by 10, which is equal to 1 amp. So basically the current is 1 amp. Now, what is the voltage drop at point A and point B if you take these points as point A and point B? So V of AB with respect to ground. So the voltage drop basically, if you ask basically what is the voltage at point A, with respect to ground. So this is your ground, okay? This is your ground. The negative pole of the battery is usually the ground, or most of them, at least I would say all the time, the ground. Nobody makes positive the ground because there is a lot of problems with that. Now, with respect to ground, basically the voltage at point A would be the voltage between this point and the negative pole of the battery, of course, because the ground is connected to the negative pole of the battery. That would be denoted by V of A. And of course the voltage at point B with respect to ground would be basically the voltage between this point and the ground. So this point is effectively basically electrically common with ground, although there is a 10 ohm resistor over here, but well, of course there would be no voltage between these 2 points because the 2 points are electrically common. But anyway, the voltage at point B would be denoted by V of B, and basically since the switch is closed, the resistance at this point between these 2 points is 0. So if the resistance between the 2 points is 0, if R is equal to 0, then V is equal to IR. The voltage drop across these 2 points, would be, which is effectively the voltage drop between point A and the ground, basically. The voltage drop across these 2 points would be V is equal to basically I, which is, well, 1 amp, times R, which is equal to 0. So that's equal to 0 volts. And you can see that basically V of A is equal to V of B is equal to 0 volts. respect to ground. Oh, I'm sorry, with respect to ground, meaning that if you put, of course, this would be the positive, and with respect to ground, of course, you would have 10 volts between these 2 points. So then you can say that V of A is equal to V of B. They are electrically common, and the voltage between these two basically wires, of course, would be 10 volts. I'm sorry, would be 10 volts. So V of A is equal to V of B, and both of them are electrically common. The switch is closed, and the voltage between these 2 points is the power supply voltage, which is 10 volts. And what is the voltage drop across the switch? The voltage drop across the switch, as we showed here, is 0. The voltage drop across the switch is 0. There is no voltage dropped across the switch. Now let's do another circuit here. Okay, so now let's suppose that you have some circuit like this. You have a circuit like this is connected to a switch, and then this is connected to a resistor, and this comes back to the power supply, and the switch is open. We have 10 volts over here, you have 10 ohms over here, and that is basically the switch is open. These are points A and B, and this is your ground. So the voltage as at point A and point B, the voltage as at point A with respect to ground, V of A, is going to be equal to, of course, 10 volts. The voltage as at point B with respect to ground is going to be 0 volts. And the current going through the switch, basically the current going through this switch is going to be I of SW, I call it I of SW, is equal to 0 amps. And the voltage drop across the switch, basically V of AB, meaning the voltage that you read on these 2 points, is going to be the power supply voltage, 10 volts. The full power supply voltage is going to be dropped across your switch, because your switch is open. And when I write V of A, that means that if you have a voltmeter over here, on your voltmeter you have this needle over here, and you have this selector over here, and you have 2 leads over here. One of them is negative, one of them is positive. This is usually a red probe or a red piece of wire is connected to this positive one, and usually a black piece of wire is connected to this negative one. Now if you connect this black piece of wire to the ground, and if you connect this red piece of wire to here, then you're reading and if you set this to, for example, to volt DC, if you set this to volt DC, then you're reading the voltage between the ground and point A, meaning that you're measuring the voltage of point A with respect to ground, which is V of A, which is 10 volts. Now, on the other hand, if you connect this lead to this point over here, you're reading the voltage between point B and the ground, and you can see that there is no potential difference here. There is just a resistor between the two leads, so you would read 0 volts there. Now the current going through the switch is the current going through the circuit, of course, because it's a series circuit. The switch is connected in series with the resistor, in series with the power supply. Or you can say that basically the switch is in series with the resistor. And then you could say that if the switch was closed, then the load was connected in parallel with the power supply, something like that. Now, since the switch is open, of course no current is flowing through the circuit, and of course then since no current is flowing through the circuit, no current is flowing through the switch. So then I of SW, the current going through the switch, is 0 amps. And V of AB is basically V of AB is if you for example connected the positive lead or the positive probe to this point over here, and if you connected your negative point over here, this is the voltage across these 2 points. And it's going to give you the whole power supply voltage, because this point is connected to the positive pole of the battery, and the negative pole of the battery is connected through this wire, is connected over here. And so you would read basically 10 volts on your voltmeter. Of course, I'm going to show you all of these basically all of these readings. I'm going to show you in a project. I'm going to show you how to work with a voltmeter, how to work with an ohm meter, how to work with a amp meter, and so on and so forth. But this is just the theory now. Now we can have another sort of basically switch over here. That is a double pole single throw switch. A double pole a single pole. I have a single pole double throw switch. So when you say double throw switch, that means that you have a common over here and you have 2 terminals over here, and then the switch can be connected either to this one or to this one. And when you say single pole, that means that there is only one switch over here. But if you said, for example, double pole, for example, double throw switch, then it would be basically one switch over here, and then you would have another switch like that, all in one package. So that would be a double pole double throw switch. So basically when you say a single pole switch, you have only one switch. When you say double pole switch, you have 2 switches over here, practically 2 switches. Now if you had for example a single pole single throw switch, you would have your switch would look like this, meaning that you would have only these 2 contacts for a switch. If you have a double pole, for example, this is a double throw switch, so a single throw switch would look like this. So for example, something like this in a package, put together 2 switches in a package. This is just one switch, these are 2 switches. Now if you have a basically a single pole double throw switch, something like this, and suppose that you have this is connected to one lamp over here, this is connected to one lamp, and this goes to the, for example, this goes to the positive pole of your power supply, this goes to the positive pole of the power supply, and this goes to the negative pole of your power supply, and then this goes to another lamp and to the negative pole of the power supply. Okay, so this is negative, this is positive, and these are the poles of your switch. So this is basically your switch over here. Okay, now if your switch is connected is in position A and in position B, if it's connected to position A, this lamp is on, is turned on. If it's connected to position B, then this lamp is turned on. So this would be A, for example, and this would be B. Okay. And of course you can see that since these switches can have at any point in time, your switch can either be in position A or in position B. It cannot be in both positions simultaneously. You can basically either lamp A is turned on or lamp B is turned on. Both of them cannot be turned on together. So that's basically meaning that basically your switch is something like this. This is a double throw switch, and this is a double throw switch, and a single pole double throw switch. So it's either, you can either put it in this position to the right or to the left. If it's to the right, then this contact over here is connected to this contact here. If it's basically, on the other hand, if it's on the other position to the left, then the same contact in the middle is connected to this contact over here. So it cannot be basically in both positions simultaneously. And that's basically that. So that's all you need to know about switches. And then in the next video we will talk a little bit about capacitors in DC circuits. So I'll see you in the next video. Thank you.